Good evening. Here is our online video, I guess, of the agenda for this evening. So I'm going to be going through the notes for 6.1, 6.2, and 6.3 that are on this video. And your homework is going to be on XYZ. And I want you to read ahead for 6.4 and 6.5, and then also complete the problems for 6.1, 6.2, and 6.3. Okay. So 6.1 is all about simplifying rational expressions. And so the first thing we need to talk about is what exactly is a rational expression. Get my pen here. And a rational expression is any expression that can be put in this form, P over Q. So it's going to look like a fraction. But the difference with a rational expression is that your P and Q are going to be polynomials. Remember, the word polynomial means that it has many terms. So it has many terms in the numerator and in the denominator. The denominator can never be zero. Okay, so remember we talked about when we were graphing lines, and we reviewed this a few times, that the denominator, when it's zero, it means that it's undefined. So let's talk about an example of what a polynomial is. We could say 3 plus x over 5. That is an example of a polynomial. We could also say x plus 2 over x cubed minus 8 could be also an example of a polynomial. Okay, so those are just two examples. So because of that rule that the denominator can't be zero, then we talk about putting restrictions on the denominator. Okay, so when for example, in this one, state the restrictions on the variable. So what that means is, since we know that the denominator cannot be equal to zero, we figure out what does x have to be to make the denominator zero. So x squared minus x minus 6, this is the last chapter we were doing, is equal to 0. And we're going to go ahead and solve for what x can be, right? So you can pause the video and off to the side, go ahead and do your squares to figure out what the binomials will be, right? I'm going to go ahead and just work through this. So here are my factors, x minus 3 and x plus 2, right? So I would do that. I could do that in the squares as well. Each factor gets set equal to 0. Again, just like the last, I think it was 5.8 that we did that, or 5.7. And then x plus 2 equals 0. Okay. So then we solve for x, and if x minus 3 can't be equal to 0, so we know that x equals 3. That's one of our possibilities. And we know that if I subtract 2 from both sides, I would get x is equal to negative 2. So that's another one of the possibilities. Okay. So our restrictions on the variable would say that our denominator can't be equal to, or I'm sorry, not the denominator, the variable can't be equal to negative 2, and x can't be equal to 3. So that's our restrictions. Okay. I guess depending on the wording of the question, we would say that x is 2, negative 2, or x is 3. But usually the way I see it is that we don't want x to be negative 2 or 3. Okay, so that's the concept of restrictions. Okay, the next is we have to talk about simplifying. Okay, so just like when you're simplifying a fraction, so let's say I had 2 over 6. Okay, the way that you would maybe you just know that that's equal to 1/3, but what you would also do, or what you could also do, is say, well, I know the numerator is 2 times 1, and I know the denominator is 2 times 3, and they each have a common factor of 2. So I'm going to cancel those out, because really 2 over 2 is equal to 1. So I know that 2 over 6 is equal to 1 over 3. Okay, so 1 over 3 is my reduced fraction. It's the same idea in a rational expression. Okay, I would factor the numerator, right? So we know this from the last chapter that it is the difference of 2 squares. So I know that my numerator, is x minus 3 times x plus 3. My denominator, it's almost what we just looked at, is x plus 2 times x minus, or x plus 3, excuse me. Okay. And again, off to the side, you could do the boxes if I'm going too fast for you, but it does factor into x plus 2, x plus 3. I look for the common factors, and I can cancel those both out because the numerator and the denominator both have the x plus 3. So I'm left with my answer, my simplified answer is x minus 3 over x plus 2. Okay. So now you might be wondering, well, what about those restrictions that you just talked about? I can't have x be equal to -2. So when we get to graphing, or when we get to we're solving the equation, then that question will come up. What could our denominator, what could the variable and the denominator not be equal to? And then it would make it, we would know in this case that x can't be equal to -2. Right, so that's going to come into play when we start graphing, excuse me. Okay, so this is our answer. Okay, all right, over on to this one. Right, so in the numerator, my greatest common factor is 10. So I'm going to factor out the 10, a plus 2. My denominator, I see that they both have the greatest common factor is 5. So 5 times a squared minus 4. Okay. But I'm not done yet. I still see this a squared minus 4 is the difference of 2 squares. So I can keep going. All right, so this becomes, I'm just going to cross this off. It becomes an a plus 2 times a minus 2. Okay, you might want to write it over. I know that I'm running out of room over here. Okay, so what common factors do we see? I see an a plus 2, that goes away. This a plus 2 goes away. I also see that just as I reduce the fractions up here, I see that this 10 and 5 can reduce. This 10 its factors are 5 times 2. Okay, that's a times. So my common factor is 5. So my final answer is 2 over a minus 2. So all that work with factoring we did in the last chapter, it's going to come into play here where we are simplifying. Okay, so that was the end of 6.1. All right, next is 6.2. So multiplying and dividing rational expressions. Okay, so how do you multiply fractions? What do we do to actually multiply fractions? We could just multiply across, or that is how you multiply fractions, I should say. I don't know why I asked it as a question. So you multiply across. So we have 3 times 10, which is 30, over 4 times 21, which is 84. Okay. But I have this note to you. Always remember to simplify before multiplying. Okay. So if we go back here to our 3 over 4 times 10 over 21, are there any factors that are in common? And you might be thinking, well, I've never had to do that before. I don't want to start now. But we need to be reducing our fractions as much as possible, because if you multiply them, if you multiply all of it, then you have more polynomials that you need to simplify, just like we just did in the 6.1. Okay, so what I would like you to do is get in the habit of canceling. I had a student once say it was cross-canceling, which, you know, I kind of agree with the words on that. So to simplify, you can cancel any numerator and any denominator. So the 3 and the 21, the 3 and the 4, or the 10 and the 4, 10 and 21. So the way that I look at this, I think, okay, well, the 3 and the 21, this is 1 times 3. And sometimes it's easier to write what the factors are. And this 21 is 3 times 7. Okay. So I know that the 3's cancel. They go away. The 10 is 2 times 5, and this 4 is 2 times 2. Okay. And I see a 2 that they have in common, so they both cancel. So I'm just canceling on the numerator to denominator. My numerator is left with just the 5, and here it's left with 14. Okay. So did I get the same answer? I would definitely get the same answer. Just making sure that I didn't miss anything. 5 in my numerator. Yep, 3 cancels. 2, yep, so 5 over 14. So I could divide both of these by 6, and I would get exactly the same thing. But it might take longer to come up with it because now I have 2 times 15, I have 6 times 5, I have a lot more numbers that I need to do in order to simplify. So that's why simplifying first will make our lives a little bit easier. Okay. All right. So now we're going to go through and do an example. Okay. So on my example, so I have 1 over v plus 10, 10v plus 30. So I'm going to rewrite this because it gives me a little bit more space. 1 over v plus 10 times v plus 3. Greatest common factor of v plus 10 and v plus 3 is both 1. So I don't need to do anything different. Here in my numerator, I see that there's a 10 and a 30, and they have 10 in common. So my greatest common factor is 10. 10 times v plus 3. Look, the v plus 3's cancel. V plus 3 cancels here and here. That's it. Okay, so you might be wondering, well, can I cancel the 10s? No, you can't, because the 10 is being multiplied. This 10 is being added. They have to be factors. They have to be multiplied. So my final answer is 10 over v plus 10. My final answer. Okay. So now we go over here. We have a lot more going on. So 7n, that's my cat, Zeus. I apologize in advance for the cat. Okay, so my greatest common factor, I see there's an n squared. Okay. I also see that the 24 and the 64, I'm just going to write them over here, 24 and 64, this is 6 times 4. 64 is 4 times 16. Okay, so there's still more. Okay, so because I know when I cancel the 4s, I still have a 6 and a 16 here. So this 6 would be a 2 times a 3. This would be a 2 times an 8. 4 times 2 times 8. Yep. Okay, so what I want to factor out is an 8. Okay, so I'm going to factor out the 8 from both. So 8n squared is my greatest common factor. My parentheses is 3 minus 8. Sorry, 3n. I know I messed that. Sorry, let me get... fix that. Okay, so it should be 3n minus 8. Sorry. 3n minus 8 times... n, or the 9n minus 24 has a 3 in common. I'm going to factor out a 3 times 3n minus 8 over 7n. Okay. The 7n's cancel. Remember, I'm left with 1s because this is really times 1. 3n minus 8 cancels. So I'm left with 3 over 8n squared. The other thing that I will see students do is they multiply all of this out, and they're left with 7n times 9n minus 24 all over, and they keep going. 24n cubed minus 64n squared, and all of that times a 7n. It just gets really icky, okay? It goes way too much. You don't need to do that, okay? So you would simplify and then multiply across, just like we did with the fraction on the previous slide. 1 times 3 is 3. My denominator is 8n squared times 1. Okay, so simplify and then multiply. Okay. All right, so now we're going to talk about division. So with division, you always multiply by the reciprocal. So my students would always remember KFC. I had never heard that before. I mean, heard of KFC, but not in terms of fractions. So they would always write down keep, flip, change. That's what they would write. So they would say to themselves, they keep the first fraction, they flip the second, we're multiplying by the reciprocal, and they change the division to a multiplication. Okay, so that's the keep, flip, change. Use it if you want. Maybe you know that. Maybe you know that or you've heard of that acronym with fractions before. Okay, so now we've set up a multiplication problem. Our process is exactly the same. So any numerator and any denominator I can cancel. So 4 is, I don't know why I wrote that again, is 1 times 4. The 8 is 2 times 4. I can cancel the 4 and the 4 here. So now I multiply. 1 times 9 is 9. Over 5 times 2 is 10. That's my final answer. Okay. So let's do some examples. Okay. So first example, these 4 n's. Okay. So again, you want to write it as a multiplication problem. Okay. So 4n over n minus 6 times 8n minus 48 over 4n. Another thing that I see students do is they forget which one they have to, which one has to be the reciprocal. So you multiply by the reciprocal. So it's the second one that gets changed. Okay. All right. So this fraction, I don't see anything that I can reduce. I'm going to leave it. This fraction, I see a greatest common factor of 8. So 8 times n minus 6 over 4n. Okay, so the n minus 6 gets canceled with this n minus 6. This 4n gets canceled with this 4n. So our answer is 8. Okay, because these are both 1s. Okay, over here, so on to problem number 2. 7a squared over, and the greatest common factor. So I'm about to tell you, so if you want to pause the video and do it on your own, that would be great. Okay. Greatest common factor is 7a squared, and then in parentheses, n plus 8 times. So I tend to factor as I go. Okay, so this is over 2. So this is going to be 8, or a plus 8, a minus 1, a. This is an a. I don't know where this n came from. I'm sorry about that. That's an a. Okay, sorry. Okay, so the a plus 8 goes away. 7a squared gets canceled here. So we're left with a minus 1 over 2. There you go. That's it. Okay. We're going to pause the video there, and then I'm going to go on to the next one. So that was just the notes for 6.1 and 6.2. All right, see you in the next video.